Hey, mathematicians, it's Justin again. We're learning about outer space in Science Club, and this article I'm reading says that the sun is about 9.3 times 10 to the seventh power miles away from Earth. How far away is that in like normal numbers?
Take a look at that 10 to the seventh power. How do we write that as repeated multiplication? It's 10 multiplied by itself 7 times. So this is 9.3 times 10 7 times. That's a lot of tens, but they're pretty easy to multiply if we remember our place value patterns. Let's start with just 9.3 times 10. How does multiplying by 10 affect the place values of the 9 and the 3? Yeah, each digit shifts to the next greatest place value. We can represent that by moving the decimal 1 point to the right. So 9.3 times 10 is 93. Now multiply 93 by 10. Again, the decimal moves one place to the right. Since we don't have any more digits, we just add a 0, giving us 930. We still have 5 more tens to go. That means we'll move the decimal 5 more places to the right, adding 5 more zeros. In total, we moved the decimal 7 times, once for each of the tens represented by the exponent of 7. And that gives us 93 million. No wonder the article wrote it with a power of 10. All those zeros wouldn't fit on the page. We're used to seeing numbers written out with all their digits, like 93 million. That's called standard form. We think of it as the normal way to write numbers. Sometimes it's helpful to have a shorter way to write these big numbers, and that's where scientific notation comes in. It's a way to write a number as the product of a number and a power of 10. The first number, called the coefficient, must be greater than or equal to 1, but less than 10. That means it has exactly one non zero digit in front of the decimal. The second number, the power of 10, is 10 with an integer exponent. Between those numbers, we use the multiplication x. So, the number in the article is in scientific notation because 9.3 has one non zero digit in front of the decimal, and 10 to the seventh is a power of 10. I think we're ready to try a scientific notation problem. This one's asking us to write -3 times 10 to the fifth in standard form. Multiplying by 10 to the fifth means multiplying by 10 5 times. Since we're multiplying a negative by a bunch of positives, will the result be positive or negative? It'll be negative. So let's just ignore the negative for now and apply it at the end. We'll move the decimal to multiply by these tens, but where's the decimal in 3? When there's no decimal shown, it's always at the end, right here. How do we move the decimal to represent multiplying by 10 5 times? We shift it 5 places to the right, inserting zeros each time. Here's 1 place, 2 places, 3 places, 4, and 5. Now we apply that negative sign, and that gives us negative 300,000. Scientific notation and standard form are just two ways to represent the same number. So if the original number is negative, then the rewritten number is negative too. I think you're ready to try one on your own. Pause the video here and write -8.2 times 10 to the seventh in standard form. First, ignore the negative sign and multiply 8.2 times 10 to the seventh by moving the decimal 7 places to the right, inserting zeros as needed. Then, apply the correct sign. Since a negative times a bunch of positives is negative, the answer is negative 82 million. In scientific notation, the exponent on 10 is an integer. So we can have negative exponents too. Let's see how that works by writing out 5.1 times 10 to the negative third power in standard form. To start, what's 10 to the negative third as a positive exponent? It's 1 over 10 to the third, which is like multiplying by 1/10 three times. How could we represent multiplying by 1/10 as a different operation? It's the same as dividing by 10. So, multiplying by 10 to the negative third is the same as dividing by 10 three times. Let's start with just 5.1 divided by 10. How does dividing by 10 affect the place values of the 5 and the 1? Each digit shifts to the next smaller place value. We show that by moving the decimal to the left. So to multiply 5.1 by 10 to the negative third, we move the decimal 3 places to the left, inserting zeros as needed. Here's 1, 2, and 3. That's 51 10,000ths. Your turn to try one. Pause the video here and write 9 times 10 to the negative second in standard form. Multiplying by 10 to the negative second is like dividing by 10 two times, or moving the decimal 2 places to the left. The decimal starts after the 9, and moving it twice to the left gives us 9/100ths.
So, when converting from scientific notation to standard form, a positive exponent results in a number that's greater than or equal to 10, or less than or equal to negative 10. That's because the place values increase as we multiply by powers of 10. Alternatively, a negative exponent results in a small decimal number between -1 and 1 because the place values decrease as we divide by powers of 10.
We can also work backward, converting a number in standard form to scientific notation. Let's try it out now with negative 271 millionths. For now, we'll ignore that negative sign and just look at the digits. For scientific notation, we need two parts, the coefficient and the power of 10. The coefficient must have one non-zero digit in front of the decimal, so where should the decimal go in these digits to make the coefficient? Between the 2 and the 7. 2.71 is between 1 and 10. Now, what about the sign? Should 2.71 be positive or negative? It should be negative. Scientific notation and standard form represent the same number, and since the original number is negative, the coefficient in scientific notation must be negative. So, we have negative 2.71 times 10 to some power. What should the exponent be? Well, the decimal is now between 2 and 7. From there, how many places would it have to move to get back to its original position? 4 places. And should the exponent be positive or negative? Since we would need to divide to decrease the place values and get a decimal number, the exponent is negative. So this is negative 2.71 times 10 to the negative fourth. Try this last one on your own. This time we're converting a really large number to scientific notation. Be sure to think about the exponent's sign. Pause the video and write 6,800,000 in scientific notation. The coefficient is 6.8. That has one digit in front of the decimal. Now, for the exponent, how many places would the decimal move to go from 6.8 back to where it was originally? 6 places. And should the exponent be positive or negative? Since we need to multiply 6.8 by 10 6 times to increase the place values, the exponent is positive. So the answer is 6.8 times 10 to the 6th. So to convert from standard form to scientific notation, we just work backward. First, we determine the coefficient, which has one non-zero digit in front of the decimal. Then we find the exponent by counting how many places the decimal would move to go from the coefficient back to the given number. To determine whether the exponent is positive or negative, we ignore the sign of the given number and just look at its digits. If the number is greater than or equal to 10, the exponent is positive, and if the number is a decimal less than 1, the exponent is negative. Thanks for learning about scientific notation with me today. Be sure to finish up your guided notes and complete practice levels 1 through 3. Until next time, keep questioning, keep calculating, and remember, in scientific notation, a little exponent goes a long way. See you next time.
Hey, hey.